The definition of acidic water has to do with the level of pH. And pH is a scale of acidic or alkaline water from 0 to 14. 7 being right in the middle, that's considered neutral. Anything below neutral is on the acidic side of the pH scale. And acidic water can be quite corrosive. Anything above 7 on the pH scale is considered alkaline. And quite frankly, there's a lot of health folks out there talking about how high pH water is actually better for you. But today we're going to talk about taking care of water that's on the acidic side and what we need to do to move it back towards neutral. Water becomes acidic basically because in the hydrologic cycle, when water evaporates and condenses in the sky to create clouds, and then those clouds get full of moisture and it precipitates back to Earth, either as rain or snow. In that process of precipitation, water combines with carbon dioxide and creates carbonic acid. So rain is slightly acid. And depending upon the Earth that it goes down through into our groundwater, it can become either higher in pH because it passes through alkaline-rich rock in the soil, or it can actually become more acidic due to the lack of those kind of minerals being in the soil. Well, when that happens, we need to do something to adjust that pH, adjust that acid water back up towards neutral. The reason that we do that is because acidic water can be very, very corrosive. By golly, if you have acidic water, you want to treat the whole house because that acid water is destroying all your plumbing. If you are seeing blue or greeny stains on your drains, that's what you've got going on. You've got acidic water that's actually eroding the copper from the inside of your plumbing. And if that's left unaddressed, what happens next is you'll get pinhole leaks. And you know Murphy's Law, those pinhole leaks are going to be behind a wall someplace and you're going to have lots of damage to repair. So acidic water is something not to be toyed around with. You definitely want to make sure that you take care of it. It can also destroy your water heater or any of your hot water using appliances. The hotter the water is, actually the more corrosive that water becomes. There's a number of ways that we attack acidic water. The most common is using a material called calcite and flow water through that calcite to raise pH. Calcite is a mineral that's very high in alkalinity. In fact, it's made a lot of calcium, and calcium is very rich in alkalinity. And by passing water through that, and keep in mind, water is a universal solvent. And as water touches stuff, it dissolves it, and then it carries away and it becomes part of that water molecule. As we get calcium and alkalinity-rich mineral back into that water molecule, pH raises. And that's the easiest way to raise pH and make it neutral. When we use calcite, we understand that calcite has some basic limitations. It is very, very dependent upon how much contact time the water has with the mineral. So the farther that we need to raise pH, the more we have to understand the limitations of what calcite can do. Typically, calcite can move pH 1 point. So if we're between 6 and 7, remember 7 is neutral, if we're between 6 and 7, calcite may get us there. So we've got to make sure we have enough calcite based upon our flow rate requirement to move pH that 1 point upwards. So the amount of calcite is going to be directly linear to how much flow rate we have. And that's calculated out in our spec sheets and so forth. Now, if we have acidic water that is more than 1 point away from neutral, say 1.5 away, then we're going to use an additive to the calcite, and it's a mineral called corrosive. Actually, it's magnesium oxide, and it has the ability to really adjust pH but we don't want to use a lot of it because it can actually overcompensate. Plus, on the side, it's magnesium, and too much magnesium in your water can act as a laxative, and you probably don't want that. So calcite's good for 1 point. We add a little corrosive if we got to raise it 1.5. If we are in low 5s, or we're even looking at acidic water that's in the 4s on the pH scale, we're probably going to go to a different type of pH adjustment. The first step beyond calcite would be chemical injection using a product called soda ash. Now that's a maintenance problem. It's very difficult to deal with. You've got to be very committed to it, but if your water is that acidic, you would be. And if it's too far for soda ash to move, if we actually get down into the low 4s, we're going to use caustic soda. Caustic soda is incredibly alkaline at a 14, and it's about the only material we can use to move pH far enough to get it neutral when we're down that low. But caustic soda is nasty stuff, and would prefer not to use that if we can avoid it. Now, if we're talking about point of use type corrections, reverse osmosis is an example where we might use a cartridge type of pH adjuster. Reverse osmosis will reduce pH by 1 point. And the reason it does that is it's stripping alkalinity out when it takes inorganic minerals with it. By dropping that pH a full point, a lot of customers like to add something to pull that pH back up. And they do that with a calcite cartridge. And that is a cartridge that's typically in line on the way from the tank to your faucet to buffer that pH back up. And if you remember, I made the comment about a lot of people like to drink water high in alkalinity. Well, there's cartridges that will do more than just calcite available, that will not only move the pH up higher, but there's also some reintroduction of some minerals for those that like to have that in their drinking water. And you can contact us separately on that if you have questions. Point of entry whole house calcite filters require at least an annual maintenance. And what happens is the calcite actually dissolves. And it dissolves because of that universal solvent thing, and the water is actually dissolving the mineral, and it's picking it up, and that's what buffers and raises pH. So eventually the calcite in that tank is going to go away. Typically on an annual basis, you're going to add more calcite back into that tank. Depending upon your flow rates and the size of the tank that you have is going to determine how much calcite you're going to need to add back in. Acidic water can be found in various places, and typically it's more prominent in certain locations than others. And a lot of that has to do with the geology that surrounds your well. If you've drilled a well in bedrock that's rich with calcium, limestone, so forth, you're not going to see acidic water. You're going to have plenty of pH. If you live in an area that doesn't have natural calcium or limestone in the ground, that acidic rainwater will stay on the acidic side as it goes down into the aquifers. The Northeast, for example, has a lot of granite in the geology, so the water stays acidic. In some cases, it actually becomes even more acidic. So the acid water is very location sensitive. But that doesn't mean you can't have pockets here and there where you can experience acidic water. So in water testing, it's always important to see what your pH value is, because that's going to tell a story on whether or not you need to address acidic water. Now, before we stop talking about calcite, there is one thing to consider. Calcium is one of the minerals that makes up water hardness. So as you can imagine, as water dissolves the calcite, and calcite is just a lot of mineral that's very calcium rich, and it's got a lot of alkalinity in it. So as it dissolves this mineral, it's going to add hardness to your water. So the trade-off is you're taking out corrosive water, but you're replacing it with slightly hard water. Depending upon what kind of hardness you already have in the water, you might have a softener that you would put this pH adjustment system before. That way the softener now is going to grab any of the hardness that the calcite filter puts back in the water. And you just adjust your water softener to accommodate the additional hardness. There's a couple of options in regard to that whole house calcite system. One system is a backwashing, typical control valve and a mineral tank that periodically it's going to backwash to stir the media up and so forth. And the other option is a upflow with a vortex tank. And that's kind of where we lean because it provides some real benefits. Let me show you. The reason we like the upflow systems is because of the way that they operate as opposed to the way a backwashing system operates. Well, the tank that the media is in, they're virtually the same. You have a tank, and excuse my drawing because the symmetry is probably not perfect, but a backwashing system has a valve on top. You have a distributor or riser tube, if you will, and down at the bottom is a distributor basket. This distributor basket is where the water flows into after it passes through the media, which is typically about halfway up. As the water flows through this media, we're getting our pH adjustment. But what happens, since it's all got to go through this little basket at the bottom, is we end up with water flow that goes right to that basket. And ultimately, we're not making use of all the media that's in that tank. So periodically, we've got a backflow or backwash. We have to move water opposite direction down the riser tube so that it lifts that media bed and stirs it up and re-stratifies it so that we can get all the media into the play. Also, when it backwashes, it's going to put 30 or 40 gallons of water down the drain. The bigger the system, the more water to the drain. So here's why we like the upflow with the vortex tank system. We've got the same size tank. We have a distributor tube that comes down the center, but instead of going to this distributor basket on the bottom, there is what's called a vortex plate down on the bottom. And water flows down the riser tube and comes up through that plate into the media. Well, if we tip this plate up on its side, it's going to look kind of like a fan blade. And the fan blades are really fine. And what happens is as the water flows up through that vortex plate, the water starts moving in a motion. And it moves this media all the time it's in service. The benefit of that is it eliminates the backwashing cycle because the media is always in motion. So we don't have to lift the bed because we've got media that's not seeing water flow. The other benefit is we're not going to dispense 30, 40 or more gallons of water to the drain every few days just so that we can stir the media up. So the upflow benefit is that we don't have to backwash, we don't have to run water to the drain, and we actually gain efficiency and better contact with the water because of the media always being in motion. We get better pH adjustment. That's the reason we like the upflow tanks. Well, that's all I've got on pH adjustment systems. If you think you need one of these systems because you have acid water, be sure and give us a call and we'll walk you through, ask you some questions, and make sure you get the right system for your need. So be sure and like our video, subscribe to our channel, and check us out on our website, freshwatersystems.com.